Hello, this is Michigan Tech Senior Design Team in the ECE department. Our sponsor for this project was ITC, International Transmission Company. We were tasked with the problem with capacitor bank protection. An introduction and a problem statement for this is our team needed to develop resilient protection scheme for capacitor banks using real-time impedance monitoring. This would enhance fault detection accuracy by analyzing impedance variations and reducing false trips, as well as improve reliability by accounting for temperature effects and external disturbances in protection logic. And to do this, we were able to validate it by using MATLAB and Simulink and testing with relay integration.
As stated, the team needs to implement an impedance-based fault detection system to protect ITC's capacitor banks. This needs to be real-time and fast to protect their equipment, as more damage can cause the longer they are exposed to undesirable conditions. The team mainly used MATLAB and Simulink to conceptualize our strategies and then test and validate our strategies. To do this, in the relay, we implemented a FIFO memory register and moving average calculations that is able to detect a capacitor element failure that happens over a short period of time. Big challenge with this and why we incorporated the FIFO register was because we need to integrate with ITC's existing infrastructure and their existing relaying system.
To test the system, we used a 9-cycle FIFO to store impedance values. We averaged the first 3 and the last 3 values in the register and measured the difference between them. The differential indicated when an element failed. It worked well in filtering out noise from temperature shifts and other random conditions. The plot shows how the moving averages and their differential tracked impedance changes over time.
This is our SEL 487V relay, which is used to protect capacitor banks, and our Doble test kit, which we use to test our relay. It injects voltage and current, and we can use it to make sure our algorithm is working. Right now, Logan over here is going to run a test through the Doble test kit, which will simulate a capacitor element failure. This light will turn red, which indicates that our logic is working and that it sees that there's current going through. It's an enable bit, and then when we start running the test, ideally after 5 seconds, this light will turn red, meaning that our relay has identified a capacitor element failing. So we can run the test. Doble is injecting. Red means it's running. Capacitor element detected.
In summary, we developed and validated an impedance-based detection algorithm. It accurately identifies both instantaneous and sequential capacitor element failures. To overcome the SEL47B's memory limitations, we implemented a 9-cycle FIFO structure. This allowed for real-time differential logic and significantly improved fault detection accuracy. It also helped reduce false trips caused by environmental noise. Looking ahead, we recommend testing logic in a live substation environment. Additional work should focus on improving fault classification, separate real failures from temperature effect. Relay coordination settings should also be refined, along with further testing of the FIFO logic under external fault conditions. Our team includes Alec Brovont, Alex Gutowski, Caleb Anderson, Logan Kelly, Beck Mattias, and Brandon O'Brien. We'd like to thank everyone who supported this project. From ITC Holdings, thank you to Esther Beaudry, Faisal Islam, and Gordy Holt for your guidance and feedback throughout the year. From Michigan Technological University, we thank Associate Teaching Professors Trever Hassell and Anthony Pinar, Professor Bruce Moore, Graduate Student Shadi Al-Shagaran, Research Associate Mark Sloat, Laboratory Supervisor Chuck Sands, and Administrative Assistant Don Pichette. Finally, we appreciate the technical support provided by Yash Shah from Schweitzer Engineering Laboratories, and we'd like to thank you for your time and attention. We're proud of what we accomplished and hope this work provides a strong foundation for future protection system development at ITC.